Hi everybody, welcome to this week's lectures. In these lectures we're going to be talking about the topic of functions. Now functions are nothing new. We have been using functions for a while now. We have been using predefined functions, such as function rect to draw a rectangle, or function ellipse to draw an ellipse. We have also been using the active mode functions. So there's more here, active mode. Set up and draw. Actually, draw is with a lowercase. So set up and draw. And in these lectures, we're going to be talking about, as promised, user-defined functions. So the goal of these lectures, I'm going to go through specific goals in a minute, but the goals of these lectures is first of all to go over the theory and the background behind functions and how they're used and how they work exactly, and also learn how to define functions of our own. But this is hardly a random topic. If you guys, in the beginning of the semester, I said that any topic that we start, if you guys are following in the course, you're going to basically feel the need for that topic before we introduce it. So right about now, you should be thinking that there is a better way to program than to write all your code inside of your setup or inside of your draw. So why use functions? First of all, is your draw method getting a little too long, or your setup method? So we are going to need functions in order to divide up our code and in order to organize it. So the code is going to become a lot more maintainable. Two principles of good programming include modularity, which means you break down your code into smaller parts. It becomes more manageable, more readable, and it reduces the number of local variables that you may need. Also reusability. So if you have a block of code separated, you could reuse that throughout your code. You never want to be in a situation where you have to copy and paste code and you have duplicate code in different places. So the specific goals of this lecture, these lectures include to be able to implement functions, to become familiar with the concept of parameter passing. This is basically sending data to a function, to develop strategies for decomposing complex tasks into simpler ones. So if you have a problem, you'll most likely have a few functions in order to solve that problem, the divide and conquer strategy. And also to be able to understand the scope of a variable. So you guys are this is pretty much a review. You should be able to understand the that variables have different scopes, and you should be able to clearly understand the difference between variables of different functions. So I think that bit is going to be more of review for everybody. So what is a function? A function is a small block of code. It's a small unit of code that can be used repetitively, and it can be called like a black box. So whenever you want to use a function, determines that you would call that function. A function is a sequence of instructions, of course, with a name that is used to be called. Function packages. Function package computation into a form that can be easily understood and reused. So basically a function packages a series of instructions. You would call these functions and also to be able to use them. Processing has some predefined functions, such as random was one that we recently used. It has mathematical functions such as pow, trigonometry functions such as sine and cosine functions. Processing, of course, provides the mechanism to create your own user-defined functions, and we're going to go over this shortly. In the beginning of the semester, we talked about predefined functions, but any function works this way. Basically, a thermostat has a functionality. It's a black box. You don't know what it is. You just know that you're supposed to hit the key on it and get it to do what you want it to do. So for example, if you set it at a lower temperature, the temperature of the room is going to be lower. If you set it at a higher temperature, the room is going to be warmer. So but basically the interface of the thermostat is a little key on top. So if you, for example, press it at the bottom, nothing is going to happen. So with a function is a black box, and you have an interface with that function. You have a contract with that function, which in this case is the key on top, or in the case of processing functions is the data you pass to them. So for example, if you look at a predefined function such as pow, so pow is a power function. What it does is that it's going to take two numbers, that those numbers must be floats. It takes two numbers and it's going to return, the key is return, it's going to return a data back when you call it. So what happens is setup calls the function pow, and it asks it to compute 2 to the power of 3. So this is setup. It has Z. Z is garbage to begin with. Then we call pow. When you call pow, function pow appears. Now we don't know what function pow does basically right at this point, but it has its own memory. It's going to receive our input, which is 2 and 3, and it's going to basically calculate it and put the result back in Z. So the result is going to be 8. In terms of control of the program, going back. In terms of the control of the program, basically you have setup, and this is the control of the program, right? So when the program, if there is no draw function, your program is gonna end at the end of setup. So this is the control of the program. As soon as you call pow, the control of the program is going to go away, and the control is with pow. And then when pow returns the answer back to setup, then the control becomes with setup. So one thing you have to understand is with programming, there is a line of control. When you call another function, momentarily the control will be with the function that you called. So in fact, in active mode of processing, when you have setup, like that, and then you have draw, So they each have a few lines of code. Basically, a processing program, that's what happens. So the control starts. You come down. This is setup. Then you go back down. You keep going down. And that is draw. And you go back here. Let me draw this larger. So you would say window closed. And if the window is not closed, you keep going back up. If the window is closed, the program ends. So that's basically the control structure of processing, where you would start, you would basically do the setup, then you would go into draw, and the draw just keeps on looping over and over again until you close the window. Now, this is the bare bones, so this is the bare minimum of what's happening in a processing program. When you end up calling functions, when you end up, for example, in setup or in draw, you call functions, what happens is, so for example, if you did call to POW, so let's say float Z, and you make a call, what actually happens is you end up taking the control. This is what happens in this case, is that you end up taking the control away from setup. You're going to have POW, and then you're going to return back to setup. So momentarily, the flow of the program is going to go away from here, and you come back there. If you call a function, if you call POW within draw, of course, you're going to keep repeating. You're going to keep repeating a call to POW within draw. So that's how the control works. It's a little bit abstract, but we're going to do some examples, and hopefully that'll become clear throughout the lecture.